Hey there, this is Mr. Wilford, and I just wanted to go through Chapter 4, Section 4 with you, determinants and the Cramer's rule. This is all about doing different things here with matrices, and what we're looking at as far as a determinant. What a determinant is really a number that we get out by doing different operations with a square matrix. For example, to find a determinant of a 2 by 2 matrix, this is an example here. What you're doing is you're kind of crisscrossing. You're multiplying, and then you're subtracting the 2. So here we have 1 times 4, and then we want to subtract 3 times 2. And when you do that, when you simplify that, you get out a negative 2. So 2 multiplications and a subtraction, and the determinant is a number, one single number from a matrix. Take a look at a couple of these examples. Finding the determinant of a 2 by 2 matrix is not too bad because you're just multiplying twice and subtracting once. What we can use this for is actually to find the solve a system of linear equations, and in order to do that we have to talk about what's called a coefficient matrix. Whenever you have two linear equations like this, if you take the coefficients and you put them in a 2 by 2 matrix, you get what is called the coefficient matrix, and they call that matrix D right here. That's what it looks like. And what you can do, there's something called Cramer's rule for two equations, two linear equations. What you need to do to find the x and y coordinates of where these two linear equations will cross, what you do is you take the constants, C1 and C2 in this case, and you to find your x coordinate, you put those in the first row, and you leave the b's alone here, and you find the determinant here of this top matrix divided by a d, which is the coefficient matrix. That will give you the x coordinate. And then to find the y coordinate, you replace the second column with the c's. You find the determinant there, and you divide that by d, which is the coefficient matrix, and that gives you your y coordinate. So it's really just another way to find where two lines intersect. Either they intersect in one point, infinitely many points, or no points at all. And that's something that we saw in the previous chapter. And you can kind of look at an example here. It's pretty easy to follow. Then, taking a look, here's another example. Then taking a look at how to find the determinant of a 3 by 3 matrix. This is a little bit more complicated, but the math behind it is not too difficult. What you do is you take a 3 by 3 matrix and you rewrite the first two columns next to it, and then you're multiplying these diagonal lines in red, and you're multiplying these diagonal lines in blue, and you take the sum of the red and the sum of the blue, and then you subtract those two. What I would suggest, you can see here is an example written out for you, but what I would suggest is to either look at your graphing calculator, and you can find the determinants that way, and that will actually give you your answer straight out. Or of course you can follow this example, and I'll show you a quick page online where you can look at a matrix calculator online as well. Let me just show you here real quick. You can also use Cramer's rule for three linear equations, and you can follow the same kind of process that we did with a 2-equation linear system as well. What I wanted to quickly show you here was this online matrix calculator. There's all sorts of cool things you can do with it. You can check it out right here, and you can even do some adding and subtracting and multiplying. If you have any questions at all, please let me know. Thanks.